Hi everybody. Welcome to my video, Understanding Morphological Features of Human Evolution. It is a tutorial to introduce you to a detailed explanation of specific aspects of human skeletal morphology. Paleoanthropologists have been analyzing skeletal morphology since they've been finding transitional humans and hominoids and hominids in the fossil record. This was the tried and true way to classify groupings until the last 40 or so years, where we've been able to really focus on other types of analyses. However, skeletal morphology still plays an important role. It is still an important piece of the puzzle that allows us to reconstruct human evolution. Morphology is simply about form and structure. Skeletal morphology is about analyzing the remains, the skeletal remains, and their form and structure. And they are grouped together based upon these analyses. Now we have other scientific tools that allow us to group finds, but again, skeletal morphology still plays a significant role. One area that really tells a story, one morphological area of the skull that really tells an important part of the human story, is called the Foramen Magnum. This term translates from Latin meaning the great window, and you'll understand this when you begin to see the picture of what the Foramen Magnum is and how it does tell part of the story of humanism, specifically related to bipedalism. The foramen magnum is the hole at the base of the skull where the spinal column fits into the skull. And where it is positioned tells the story of whether you are an upright walker or you are what we refer to as a knuckle walker. The foramen magnum is located halfway between the front and back of the skull, so the head is balanced on the vertebral column. Now this is in humans, particularly modern humans and upright walkers. In the great apes, the knuckle walking apes, the foramen magnum is positioned more posteriorly, and its opening is slanted more towards the back of the skull. This is a characteristic related to horizontal posture. Heavy neck muscles. Look at the neck of these chimpanzees. Heavy neck muscles are also related to horizontal posture. They hold up and move the head, and this is really quite pronounced in these chimpanzees. And again, notice here the foramen magnum, the position of the foramen magnum of a chimpanzee, of a modern chimpanzee. Now, the modern human foramen magnum, again, is located fairly centrally, okay? And our neck doesn't play the same role in holding up our head as it does for knuckle walking apes. Certainly we have muscles, but by the virtue of the position of the spinal column, this provides for upright posture. Here again, notice the picture of, notice on the picture the location in the modern human of the foramen magnum. Now, what's interesting about the Australopithecines, or this particular sample, is the basiocranial inflection. Sometimes you'll hear this term be referred to as basiocranial flexure. But this is where the back of the brain case has rotated forward and the facial skeleton has moved backward and downward. And you can see this quite nicely in this specimen here. Sometimes this specimen is referred to as Mrs. Pless, even though it's actually a male. But when they originally found the specimen, they thought it was a middle-aged female. But most paleoanthropologists and evolutionary biologists now agree that this is a male. It was discovered in 1947 in South Africa. So, and one of the great aspects of this specimen is that it is a nearly complete cranium. So it really does a great job telling the story related to bipedalism. Now, sometimes you'll hear Australopithecines or Australopithecus be referred to as transitionals. And a lot of this is related to morphological analysis. And look and see the position here, right here, where of the foramen magnum here. And you can actually see the basiocranial inflection. And this increases from apes as we move to humans. Now, certainly as we've talked about in class on numerous occasions, this is not a nice, neat kind of lineage. But this morphology allows us to really kind of at least see the connections. We're not ever going to be able to draw a straight line. And the notion that we came from monkeys is quite erroneous in understanding the complexity of the nature of human evolution. But I did want to show you the foramen magnum of this particular specimen because it is such a complete specimen, and we really can see the basiocranial inflection and how it's transitioning from, go back to the chimpanzee, here it kind of transitionals, and then into the modern human position of the foramen magnum. Another specimen I'd like to show you in the video and introduce you to is, and this is part of my bias towards Neanderthals. I find Neanderthals to be fascinating, and there's been a lot of new and recent research related to Neanderthals, and that's been quite exciting. But this specimen is from La Chapelle, and it is a beautiful specimen. It's absolutely beautiful. But look at the position of this foramen magnum here. It is positioned right centrally. No question, we know that Neanderthals, certainly they were barrel-chested and a little shorter and a little broader from the specimens that we do have. But no question, they did not drag their knuckles. They were upright walkers. They weren't really bent over as many of the characteristics or the stereotypical characteristics that we have of Neanderthals. They did not drag their knuckles. So I just kind of wanted to end the video showing you the position of the foramen magnum of this Neanderthal specimen from La Chapelle. It's a beautiful specimen. But it clearly indicates upright walking. Not dragging the knuckles, not bent and hunched over, leaning forward. So I just think that this is a nice way to end our short tutorial of the foramen magnum and how understanding this morphological feature of the human skull tells part of the story of bipedalism and human evolution. Thanks for listening. Bye-bye.